Okay, now we have a practice example for population proportions and the difference between population proportions. So we have two populations, one coming from medication A, one coming from medication B for hives treatment. And we're looking at percentages that still have hives after taking the medication. Okay, so we want to first look at medication A, determine the sample size and also the number that counts the ones that still have hives 30 minutes later. So the first, medication A, 20 out of a random sample of 200. So we've got X is 20, the sample size is 200, so that means that P prime is 20 over 200 or 0.10. Now for medication B, 12 out of another random sample of 200 had hives. So that proportion, that sample proportion is 12 over 200, and that gives us a sample proportion of 0.06. All right, and our goal here is to test at a 1% significance level. So our hypotheses are going to be, first of all, we always test if the difference between the proportions is equal to 0. So no difference between the two populations, so no diff. And the alternate is there is a difference, and we can use not equal to, greater than, or less than. And in the wording we see that we want to determine if there is a difference. So this is going to be P1 minus P2. There's no indication of less than or greater than, so it's just not equal. Step 2 is the test statistic. We kind of have a preliminary calculation for the test statistic, and that is P sub C, and that's where we take x1 plus x2 over the sum of the sample sizes, n1 plus n2. So for our example, we take 20 plus 12 over 200 plus 200, and we get PC is 32 over 400, which in decimal form is 0.08. Now we can find the test statistic, which is always going to be z because it's proportion. So the formula is we take P prime 1 minus P prime 2 minus 0. Obviously, you don't really have to do that, but that is like that 0 that's in the hypotheses. And then that's over the square root of PC times 1 minus PC times, in parentheses, 1 over n1 plus 1 over n2. All right, so let's plug those things in to get z for this example. So P prime 1, 0.1, minus P prime 2, 0.06. Then all over the square root. PC we said was 0.08. So 1 minus PC is going to be 0.92. And then we've got 1 over 200 plus 1 over 200. And plugging that into your calculator, we're going to get a z-score of 1.47, rounding to 2 decimal places. Now we want to find the p-value. We're going to use the p-value calculator that's posted on Foxtail. It's the same one we used last week with Chapter 9. So we're going to plug in the z-value that we calculated, 1.47. And the other thing that we need to indicate is that this is a two-tailed test, and it's a two-tailed test because we have a not equals in the alternate hypothesis. All right, so then we go ahead and calculate that value, and that gives us p-value equal to 0.1416. Finally, we want to come to the conclusion, so we're going to compare that p-value with alpha, the significance level. And here we have the p-value 0.1416 is quite a bit higher than our alpha of 0.01. So since p-value is greater than significance level, we do not reject the null hypothesis. All right, so we can't say that the proportion from medication A and medication B of patients with hives is different.